Welcome back to the deep dive. Today, we're really focusing on the very sharp edge of agent development.
The really tricky part.
Exactly. So if you, the listener, are focused on what Anthropic calls raising the ceiling of intelligence,
Right.
that crucial step of building, reliably powerful, high-performing agentic systems, well, then you are exactly who we are talking to.
Yeah, that's really the core mission here. I mean, we all see the raw power of these models of Claude.
Of course.
But the real difficulty for developers is translating that intelligence into a consistent, robust agent that, actually does what you want it to do.
Right. One that doesn't just fall over after a few steps.
Exactly. So what we're doing today is synthesizing Anthropic's platform evolution. It's like the scaffolding they're building around Claude to let it be a truly autonomous agent.
And we're going to use their agentic coding product, Claude Code, as a kind of case study throughout this.
Yeah, to keep things grounded in what this looks like in the real world.
Okay, so let's unpack this framework.
Ready?
It seems really logical, breaking down this huge problem into three interconnected pillars. First, it's about harnessing Claude's capabilities through specific API features.
Yep.
Second, and this is often the biggest bottleneck I see, is managing Claude's content window.
Oh, absolutely. It's like mission-critical working memory that needs to be kept clean.
And the third pillar, which sounds pretty ambitious, is about providing the infrastructure for autonomy.
Which really means giving Claude a computer a safe place to run its own code and scale up. These three things, they directly address the biggest pain points in building agents today.
Okay, let's start at the beginning then. Harnessing capabilities. We're talking about core model behaviors, right? Like thinking and using tools.
Yep, things that are now being exposed to developers as explicit features they can control. So, the first capability is thinking and reasoning.
Which sounds, I don't know, a little basic.
It sounds basic, but the finding here is actually really powerful. What Anthropic found is that Claude's performance on complex tasks scales directly with the amount of time you let it deliberate.
Ah, so it's not just about a fast answer. It's about quality.
Exactly. It's about giving the model internal processing time. So to make that useful, they exposed it as a feature where you, the developer, get to decide how much time Claude gets.
Okay, so if I'm using Claude Code for a really complex debugging task, I'd want it to think longer.
Right.
But if I just need a quick doc string generated, I want a fast, cheap answer.
That's the trade-off, and it's a critical one. They managed this deliberation time with what they call a budget.
A budget, okay, in terms of money.
In terms of tokens, you specify how many tokens Claude is allowed to spend internally on its thinking process before it has to give you an answer.
So you're forcing the developer to explicitly balance cost and latency against performance for a given task.
Precisely.
That raises a tough question, though. For a developer trying to scale this, how do you know what the optimal budget is for some, non-deterministic task?
Well, that's where the agent platform starts to get smarter. You set the ceiling, the maximum it could use, and the agent uses it when it needs it.
So for Claude Code, if it fails, a debug attempt.
It might request a bigger budget for the second try. Your initial setting is an informed guess, sure, but the key is that this budget is now a dynamic control knob for performance, predictability, and cost. It's a way to tune the model's internal behavior.
Got it. Okay, let's shift to the second core capability, which is tool use. This is where the agent actually starts doing things in the world.
Right, and the material really stresses that Claude has gotten very, very reliable at this, what the industry calls function calling.
Okay.
The API gives you built-in tools like web search, but the real power is in the custom tools. And defining one is designed to be super low friction. All you need is a name, a description, and an input schema.
So the model's intelligence is not just in how to use the tool, but in figuring out when it's the right tool to use and passing the correct arguments.
Exactly. Reliable function calling has kind of scaled, so developers can now trust the model to manage its own execution pipeline.
Reading files, writing to them, searching databases.
Running tests, whatever it needs to do as part of its plan. I mean, look at Claude Code. It's using a massive battery of tools all the time. It decides on its own, okay, I need to read this file now to do the next step.
And all that reliable tool use must just generate a mountain of data, right?
Yeah.
Every file read, every test result, it all gets fed back into the context window.
It does.
Which brings us perfectly to that second pillar, maybe the biggest hurdle for developers. Managing the context window.
You absolutely hit the nail on the head. Context management is often the difference between a high-performing agent and one that just, loses the plot after 3 steps.
And for an agent like Claude Code, It must be a constant juggling act.
It is. You have the initial instructions, the code base itself, design docs, and then, yeah, the results of hundreds of tool calls, all fighting for space in that working memory.
So the goal is to keep the context clean, optimized, relevant.
Yeah.
And Anthropic is tackling this from 3 different angles.
That's right. External access, memory storage, and active editing.
Okay, let's start with external access. The Model Context Protocol, or MCP.
MCP is, I think, maybe the most important concept here. It's a standardized way for agents to interact with information that's outside the immediate context window.
So stuff not in the prompt.
Exactly. Think of it like a standard for outbound communication instead of trying to cram an entire GitHub repository into the prompt.
Which is impossible.
Totally impossible. The agent uses MCP to talk directly to external systems like GitHub or Sentry.
I'm tracking the idea, but for our more technical listeners, does this mean it only works with, clean modern APIs, or can it handle legacy systems?
The focus is on standardizing the agent's interaction, no matter what's behind the API. And the main finding is that letting the agent dynamically pull context from an external system gives you way better performance than just pre-prompting it.
So the agent learns how to find the info, rather than trying to fit the entire world into its head.
You got it. It makes the agent way more scalable and flexible.
Okay, so MCP is about pulling new context in. What about the memory tool? That sounds like it's about keeping context out until it's needed.
That's the exact distinction. The memory tool helps the agent store important, reusable context outside the window, but gives Claude the autonomy to pull it back in when it decides it's relevant.
And the initial design is a client-side file system.
Yeah, which is powerful because it means the developer keeps full control over the data, but Claude decides when to retrieve it.
So Claude Code could use the memory tool to quickly grab, say, a company's component library or my personal Git workflow preferences without that stuff cluttering up the main conversation.
Precisely. And the third piece of this puzzle is context editing. So if you have data coming in via MCP and you have knowledge stored out via the memory tool, context editing helps you actively clear out irrelevant info that's already in the active window.
And they started by targeting old tool results. That seems counterintuitive.
It does, but they are important, just often only for a moment. If Claude Code runs hundreds of tests, those massive text outputs take up huge chunks of context.
Ah, I see.
The insight was that those older results often aren't super relevant later in the session, but they kill performance. Clearing them out frees up that valuable real estate for what's happening right now.
This all sounds great in theory. But what was the quantifiable impact of doing all this?
This is the really critical takeaway for you. Anthropic found that just combining the memory tool with context editing resulted in a 39% bump in performance on their internal evaluations.
39%. That's a massive increase.
It's huge.
Yeah.
And it just underscores that context management is arguably more important for performance than just raw context size.
Wow. And while all this smart optimization is happening, the raw capacity is still growing up to, 1 million tokens for some models.
Right. It's a dual strategy. Give the agent more room, but also teach it the discipline to use that room wisely. And they're working on teaching Claude to better self-assess its own context limits.
Which sets the stage perfectly for the final pillar, enabling agent autonomy by giving Claude a computer. This gets at that big question of how much scaffolding an agent really needs. The idea is, look, if Claude can write code, it has to be able to run that code autonomously to produce professional results.
And that idea immediately creates these huge infrastructural headaches. I mean, when they launched Claude Code on web and mobile, they ran into this right away.
Right, because if a user kicks off a complex task and then just walks away,
suddenly Anthropic is responsible for providing a secure, persistent, scalable environment for running totally arbitrary, unapproved code.
That's a massive challenge. You're talking about container orchestration at scale, security isolation, session persistence.
It's not just pointing a Python interpreter at a script. It's spinning up and tearing down thousands of isolated micro VMs per minute safely. The solution they landed on for the ATI is the code execution tool.
And this really simplifies things for the developer.
Massively. It lets Claude write and run code in a secure sandbox, but all the complexity, the containers, the security, the orchestration is handled by the Anthropic platform. The developer just uses the tool.
So I can ask Claude to build a feature, and it can just execute its own plan, writing and running tests inside that isolated box, getting instant feedback on its own work.
You got it.
Okay, so you've given the agent a computer. How do you give it domain expertise? It needs more than just a runtime.
That's the job of agent skills.
Yeah.
And we shouldn't think of these just as folders with scripts. They're more like modular, context-aware behavioral frameworks.
So a skill is a package of scripts, instructions, resources.
Exactly. And Claude uses its reasoning to decide, okay, this request needs my web design skill, and then it autonomously pulls that curated expertise into its context and executes it in the sandbox.
And this is where it all comes together.
This is where it all comes together. The performance gain is when you integrate skills with the other tools. The skills provide the expertise, and tools like MCP provide the access to the external context needed to use that expertise.
Okay, can you give us that final example that ties all three pillars together?
Sure. Imagine you ask the agent to build a new landing page. First, it budgets its thinking tokens. That's pillar 1 to break down the task.
Right.
Then it activates the web design skill from pillar 3, which pulls in the company's design system. At the same time, it uses MCP from pillar 2 to fetch the latest API docs from an external system. And finally, it writes and executes the code using the code execution tool, pillar 3 again, all inside its secure sandbox. The result is high quality, it's cost efficient, and it follows all the company patterns. That's the whole architecture in action.
That really clarifies how interdependent all these systems are. Okay, so to recap quickly for the listener, the strategy is this constant evolution on three fronts. Improving capabilities like the thinking budget, enhancing context management with tools like MCP and memory, and strengthening the underlying infrastructure for safe, autonomous code execution with skills.
Right. And that infrastructure piece, the sandboxing and the autonomy, it raises a really provocative question for everyone building these systems.
Okay.
If the trajectory is truly toward letting an AI agent autonomously manage its own execution, pull in context from enterprise systems, and leverage tailored skills, well, does the future of professional development shift entirely away from programming the agent's actions to just curating the agent's environment and expertise folders?
So what is the role of the developer when the agent is the one doing the work?
Exactly.
A great point to end on. Suggesting the future of engineering might be less about writing functions and more about managing knowledge bases. Thanks for diving in with us today on The Deep Dive.
My pleasure.
We'll catch you next time.